Bismillahirrahmanirrahim. In this video we'll talk about process management, okay, and also we'll identify the CPU and memory intensive processes, how we can start a process, how we can kill a process, and how we can restart a process. Okay, it's very simple. First of all, what is processes? Processes are applications that runs on the system. So there are hundreds of thousands or hundreds of processes actually runs on a system that makes the OS and eventually whatever the application it runs on it. So let's say Apache web server is a web server process that runs on the server, and in order for it to facilitate, in order for it to run on the server, there are other processes, system processes, operating system processes run on the server to let the Apache web server run on the system itself. So a running computer is nothing but a bunch of processes running together to make the environment available for other applications to run. Okay, so how do we see the processes? PS, let's say PS-EF, let's do pipe more because there are lots of processes running. So as you can see here, the user ID who started the process, the PID or PID, the process identifying number, the parent process who started the child process, so this is the parent process. So process 0 actually started the process 1. So this is the parent process, this is the PID, which is natural that PPID, parent process identifier, or the parent process give birth to a child process. Okay, as time TTY, terminal association with the process, the time is, since it is running on the CPU, and the command itself that started the process. All right, the time slot actually that is for the CPU. All right. So let's see, there are lots of other ways to see the processes. Let's say if we want to see in a GNU way, which is PSAUX. Okay, user who started the process, the PID, the percent of CPU it is taking, the percent of memory it is using, rhcse, status of the process, whether it is sleeping or not, or start time, okay, the time slot, and the command itself that started the process. Okay, so let's say we want to see a particular process, like for example PSAUX pipe grep SSHD. Using SSH we did logged into the system. Okay, so this is the SSHD daemon running on the system. All right, and this is the process that we used 9049 to log into the system. So let's say if I log into itself, say for example localhost. Okay, let's type the password. Okay, now if I check the process again, oops. Okay, as we can see here, this is the process is used to log into the system itself. Okay, SSH to the localhost. So we don't specify any particular process ID, the system assigns the process ID whatever it is necessary. Okay, there are lots of commands to look at the processes. All right, we'll not go over all of them, but let's say we'd like to see how a particular application is running. All right, so let's see. Okay, looks like the HTTPD is not running, so let's start. I think this system does have HTTP installed. HTTPD. Okay, now let's check the processes. All right, so here are the processes, process IDs, Okay, these are the process ID. So let's start with something so we can kill this process, kill a process. Let's say let's start a dd. Let's start a dd command, disk to disk copy. Okay, let's say bs equal to 4m. Let's say count equal to, let's say 1024. Okay, let's create, see, 1024 is fine. Alright, so that's will basically will create a file about 4 GB size. It will write this data to this file. Alright, before we start, let's open another session on the same server. Okay, let's see, ps aux pipe grep dd. Where is the dd is running? Okay, this dd is related to something else. Let's look at let's say file 1, for example. See, it is not running. The command we are about to run, grep-b grep. Okay, see, nothing is running. Alright, now let's start the process. Okay, now let's come over here, and as we can see, it is running with PID of 9754. Alright, 9754. So let's say if we want to kill this process, kill -9. Oops. Kill -9 is a sure kill. Alright, as you can see here, see, it says killed. Okay, so let's start the process again. Alright, let's come over here and find the process again. See, now it has 9787. Alright, so let's see, top. That's another utility to look at the processes that gives a lot more information. So as you can see here, its nice value is 0. Okay, so what is the nice value? Nice value is a value on the process that tells how it is running. So the value is from positive 19 to negative 20. As you can see here, this process is running with the negative 90 priority. Okay, nice value is also called a priority. So the more negative the value is, the highest priority it has with the CPU. So let's say 0 is normal priority, negative 920 is the highest priority. Okay, positive 19 is the lowest priority. Okay, so let's see how we can change this value. Looks like it is exited. We'll start it again, and then we'll change the value. Okay, see, it did exited. Let's increase the value a little bit so it will run for a little longer time. All right, okay, as you can see here, it is exited. So let's run this command again, and let's run the top. Okay, see, it's running right now. 9865 is the CPU process ID. All right, so let's rhce this value. Okay, let's see how we can do it. Right now it is running with the priority of 0, so let's do rhce -n, let's say 19, new value, -p, the process ID is 9865. Okay, see, it says the old priority was 0, now it is 19. Oh, Okay, as you can see here, it is running with the lowest priority. Looks like it is exited. All right, let's run this command again. 743. Let's do 4,000 times. Count equal to 4,000. All right. So as you can see here, it is now 9931. So let's renice this process. Let's say this time we'll do -19. Oh, sorry. That's 99931. Okay, and let's take a look at the process. All right, as you can see here, it is running now with -19. Okay, so there are lots of examples on the attached or associated doc, the lab doc. Okay, follow those. All right, now let's talk about the log files. Okay, which is very important. Okay, systems black box. Okay, that's exactly tells, well, not exactly, but let's say about 99% of the time it tells what happened to the system. While the system is running, it generates lots of logs. Okay, let's say one of them is dmesg. Okay, we can use the dmesg command to see the logs that is generated on the system, or also we can go to var log messages to see the system generated messages. Second var log, oh come on, var log okay, it cannot open. That's because we have taken the file system became 100% full, I believe. Yeah, see, that's because of this command we ran. All right, let's remove that file. So it was opt file1. Okay, now if we take a look at it, see, it has some room now. So now let's open the var log. Okay, as you can see, this is the system log. While the system is running, it generates this type of logs. Okay, there are lots of other commands we can use. One of them is blame, system deanalyze blame. Okay, that will tell you status of the processes. And how about journal.ctl? Okay, that also tells the status of the processes. All right, let's say journal.ctls. Let's say we'd like to see only the errors from the journal.ctl command -p err. Okay, anything related to the error. And let's say if we would like to see the processes or the log files in continuous fashion, we can do tail-f var log messages. So while the system is generating any message, it will show up here. So let's see if we go here. Okay, so let's say on this window, let's generate a alarm using the logger command. Let's say this is a test for the system to generate some alarm. Okay, hit enter, and let's say on this window we have tail-f running. As you can see here, it is right here now. All right, so let's say if we do vi var log messages, shift G, here we go. whatever we generated, it is right here. Okay, there is another one I might have generated before. Alright, so inshallah we'll see you on the next video.